Good morning, 10th, 11th grade geometry class. Glad to see everybody. Hope everybody had a great and safe weekend. Some of you guys and girls have not got your homework back, so make sure you get your homework in, page 36 and 37. That's very important so I can get that checked, all right? So we're going to get started. We're going to just do a quick review over our trigonometric ratios, and then we're going to get into, we're going to continue with those trigonometric ratios, but do a little something different called the angle of elevation, the angle of depression, and then we're getting set up for, getting ready to take our self-test. So let's pray, and then we'll get started this morning. Our Heavenly Father, grant us great wisdom. The students, I pray to work hard, to work diligently. I pray that you would give me the clarity of thought, clarity of speech to be able to teach some of these rules and principles of geometry. Then we'll give you the glory and the honor. In Jesus' name, amen. All right, so we're going to pick up on page number 31. Page 31, just quick review of trigonometric ratios. We have our ratios up here. Remember, there's a couple ways I told you to memorize those. We have, first and foremost, one way we can memorize this is we say chief SOHCAHTOA, which is, again, the SO is the sine ratio, which is the opposite over the hypotenuse. The CA is the cosine, which is the adjacent over the hypotenuse. And then TOA, which is the tangent ratio, which is the opposite side over the adjacent side. Another way, if you remember, a silly way we can remember this is some old horse caught another horse taking oat away. Be sure you memorize those. Very important, okay? And so let's quickly look at this right triangle here, and then we'll quickly review our homework, and then we'll go on. We have a right triangle here. Remember, the side of the hypotenuse. The hypotenuse is always this like the side that's opposite of the right angle of a right triangle. Then these other line segment ABC and line segment AC, we call those legs. So leg A and leg B. So we're just going to quickly do a couple of these for tangent ratios, sine and cosine, and then we'll move on to our angle of elevation and the angle of depression, okay? So the tangent, all right? So let's find the tangent here. If BC, let's say BC equals 9, AC equals 17, let's find the tangent, all right? So the tangent of angle A, we'll do that one first, and then the tangent of angle B. So the tangent ratio, again, is tangent equals, all right, so actually we're going to go, we'll put the angle here since we're looking for angle A. The tangent of angle A equals the length of the side opposite. Now, if this is angle A that we're looking for, the side opposite would be, good, 9 over a side adjacent. So the side adjacent would be a side that, again, is shares a common vertex with the angle there. So that would be 17. Okay, get your calculator out, and then we're just going to go 9 divided by 17. So 9 divided by 17 would be 0.5294. If we wanted to see the measure of the angle, simply you have your table. You can take your table, look up in your tangent section 0.5294, and you can simply find the measure of the angle there. Now, the tangent of angle B. The tangent of angle B, okay? So we have the tangent of angle B. So let's quickly erase our numbers here. Oh, let's leave our numbers here. All right, so we're looking for the tangent of angle B, okay? So let's have Josh Baruch. Good morning, Josh. Hope everything's going well. Josh, what is the side opposite? If this is angle B, Josh, what is the side opposite? And then how about we have Hannah. Good morning. Why don't you follow up? Side opposite of angle B, very good, is 17. And very good. And then the side adjacent, Josh, then Hannah, you follow up, would be 9. Very good. So 17 divided by 9 would be 1.8889. Again, you can look up in your chart to see what measure that angle is. So that is the tangent ratio. Now let's go quickly to our homework, which was page 36 and 37. Page 36 and 37 in your textbook here. All right. Page 36, we looked at the sine and the cosine. Number two on page 36 was for homework, so let me draw our right angle. We got angle A, triangle ABC. There's our right angle there. Okay, if BC equals 3 and AB equals 15. Now, one thing you want to remember, class, is that anytime we have the hypotenuse, all right, the length of the hypotenuse is given to us, we're always going to use either the sine or the cosine. Now, what determines if we're going to use the sine or the cosine is whatever side is given to us. Okay, so if it's the side adjacent or if it's the side opposite, that'll determine whether we use the sine or the cosine. Now, let's look at number 2. So BC is 3, AB is 15. We want to find the sine of A. All right, so the sine of A. And then we want to find the measure of angle A. All right, so we're going to use the sine, which is the side opposite over the side, over the hypotenuse. Okay, so let's look at this one here. So, all right, the sine of angle A. Okay, so if this is angle A here, okay, it is opposite over adjacent. So how about we have Gabe? What is the side opposite of angle A? And then we'll have Joe. How you doing, Joe? Good to see you this morning. How about we have Joe? What is the follow-up with Gabe? The side opposite. Good. So, BC, okay? So we're going the sine, so opposite, which would be side, the length of the side opposite, over the hypotenuse, Gabe, and then Joe, you follow up. Good, we have 15. And then we're simply going to go 3 divided by 15. 3 divided by 15 would be 0.2000. Now simply take your table, open your table, okay? We're going to go to your tangent column, look for 0.2000 or the number closest to that, and then go to the left-hand side there, and then you will have the measure is approximately the measure of angle 12 degrees. 12 degrees. So in sine A would be 200, and then the measure of angle A would be approximately 12 degrees. Okay, that's how you find the sine. Now, page 37, we had to do 5, 7, 9, and 13. So quickly, we'll go over one each, and then we'll get the answers. Make sure you have the correct answer for homework. Okay, so, all right, again, I erased my triangle, hello. All right, this is A, B, C. All right, so this is for number 5 and number 7. So number 5, all right, so AB is 11, and the measure of angle B is 11 degrees. We want to find, okay, find the unknown lengths of the right side of this right triangle using the sine ratio. So we have 3 elements to each ratio, okay? So we have the lengths of either leg, and then we have the sine. So all we need is 2 of the 3 in order to solve. Okay, so, all right, we do have 2 elements. We have the hypotenuse and we have the angle. So here's how we would do this. We're just going to plug in the numbers that we know. So the sine of 11 degrees is equal to, again, the sine is side opposite over side adjacent. We want to find the length of AC. So it would be x over 11. All right, now get your chart out. So 11 degrees. Let's look at 11 degrees in your column on the very left-hand side, and then go over to the right and then to the sine column, and we have what here? All right, so I believe we have 0.1908. 0.1908 equals x over 11. And then we're going to divide, or excuse me, get x by itself, so we want to multiply both sides of our equation by 11. So x is equal to, get your calculator out, what's 11 times 1.908, 1.908, and you should have 2.9. 2.10. The length of AC would be 2.10. All right, so that was your homework for number 5. Number 7, I'm just going to give you the answer. Number 7, the length of BC would simply be 9.06. 9.06, okay? Now let's look at number 9 and then number 11, okay? We'll do 9, 11. This is the cosine ratio, okay? So let's erase this. Okay, number 9 and 11. So we have, all right, here's our right triangle. We have triangle A, B, C. Okay, now we're finding the cosine. Now the cosine, all right, is the side adjacent over the length of the hypotenuse, okay? So let's go quickly do number 9. Number 9, we have BC is 15, and we have AB is 22. We want to find the cosine of B, and then we want to find the measure of angle B, okay? So let's take our elements, let's plug and chug here. So the cosine of B is equal to adjacent, okay? If this is the angle that we're looking for, it would be the side adjacent over the side hypotenuse, the length of the hypotenuse. So 15 over 22. Take out your calculator, do 15 divided by 22, and you should have 0.6818. 0.6818. How about we have Emmy and then follow up with Gianna? Good morning. Find 6818 on your cosine column in your table. Then you want to go over to the left and find out what measure of angle that is. I'll give you a few minutes, a few seconds. Why don't you do that, Gianna? And then Emily, you'll follow up. Number 9. All right, very good. So 6818 equals approximately, let me put this answer in here, approximately 47 degrees. 47 degrees. So again, obviously we don't have this exact number on the table, and so what you want to do is you want to find the number that's closest to 6818, and then we'll say approximately 47 degrees, all right? So that's how you find the cosine. Look at number 11. All right, number 11 now, okay? We'll do number 11 together just by way of exercise, and then we will, okay. All right, number 11 now. So again, we're finding the unknown lengths of these triangles, and again, all we need is 2 of the 3 terms of these equations. So number 11, we have AC is 2, and then we have measure of angle A is 82 degrees. We want to find the length of the hypotenuse, which is AB, okay? So again, just taking all the information that we know, we have the cosine of angle. So I'll write the angle in here. So of 82 degrees is equal to, again, adjacent over hypotenuse. So a side adjacent would be 2 over the hypotenuse, which is x. Now let's get your table out. Let's find 82 degrees on your chart. Then you're going to go to the right to the cosine column, and the measure of 82 degrees would be 0.1392. Okay, Liam, good to see you, Liam. Hope everything's going well, and did a great job on your checkup the other day. Really proud of you. What do you have here, Liam? How do I get x by itself? What do I need to do? And then why don't we have Caleb? Why don't you, Caleb, follow up? Good, we need to divide both sides, or multiply both sides by x. So 1.1392x. Again, Caleb and then Liam, follow through, get x by itself. Good, we want to divide both sides by 1392. X equals, okay, get your calculator out, do 2 divided by 0.1392, and what do you have here? You should have 14.37. 14.37. So the length of AB would be 14.37 437. That's the answer for there. Lastly, number 13, I'm just going to read you off that one, number 13. The answer for number 13 is 15.43. 15.43. Again, great job. Some of you have not turned your homework in. That needs to be turned in as quickly as possible. We're going to pick up on page 38 now, okay? Page 38, as we look at the angle of elevation and the angle of depression, okay? So let's say we have a building here, okay? There's our windows, okay? All right, we have our building. Let's say this is the ground here, and there. All right, there we have Josh Baruch. Let me give you some hair, Josh. There you go. That's your bed head. All right, now let's just say, okay, let's just say this is the horizontal, and let's just say that this person, Josh Baruch, for sake of illustration, Josh, that you are looking at the top of the roof, okay? And let's just say there's a bowl of ramen noodles. I don't know what a bowl of ramen noodles are doing up on the roof, but if they're up there, I know, Josh, you're all up in that, all right? So we got a bowl of ramen noodles up here. So we see here, what is the angle of elevation? So this angle that is formed, okay, between the horizontal, and we see this line that's above the horizontal there. This is called the angle of elevation. The angle of elevation. I want you to highlight that in your book. The angle of elevation. It is the angle formed by the horizontal line and the line of sight above the horizontal line to the object. So this is the horizontal. This is the line above it. This is called the angle of elevation. Now here's what's very important. We see that we have a right angle formed. And determined based on whatever sides they give me, we could use either the sine, the cosine, or the tangent to find any of the lengths of the sides or any of the measures of the angles. So again, that's why you need to know the ratios and the sides that they go with. So this is called the angle of elevation. Now let's just say, okay, let's put Josh Baruch up on top of the roof, okay? And he's looking down here at a hot dog cart. All right, Josh, I'm just messing with you, Josh, but I know you like your hot dogs. All right, now, what do we have here? And so now, if again, we have, this would be the horizontal, okay? And again, all right, so let's just say here, okay, you're looking downward, so this angle that is formed here now is called the angle of depression. The angle of depression. Now, I want you to notice the definition here, okay? Highlight this definition. An angle of depression is the angle formed by the horizontal line and the line of sight below the horizontal to the object. To the object. So here, all right, here's the horizontal line. Again, we have another right angle that is formed here. And so basically, again, right, we can go here, okay? And then depending on, again, the hypotenuse, the sides A and B, we could find either one of the trigonometric ratios. So the angle of elevation and the angle of depression. The angle of elevation, again, the sight line is above the horizontal, and the angle of depression, the sight line is below the horizontal. Let's do a couple of these. Let's look at page 39. Page 39 together. Let's do some of these. Okay, so let's erase this. All right, we have number one. Okay, we have a telephone pole. You see the telephone pole, okay, that extends up. And we have okay, let's read it. A telephone pole 15 meters high is to be supported from its middle. Very important. The telephone pole, all right, is 15 meters high, is to be supported from its middle. And the support wire is to form an angle measuring 50 degrees with the ground. How long must the support wire be? How long must the support wire be? Okay, so now, what do we have formed here? We have a right triangle. We have a right triangle that's formed. We want to know if this is the right angle, class. All right, how about we have Bobby Huntlock. Good to see you, Bob. Haven't heard from you in a while. But, Bob, if this is the right angle, then what is this line here? The hypotenuse. Very good. Okay, now let's quickly, what two trigonometric ratios, Bob, and then follow up with Preston. What two trigonometric ratios deal with the hypotenuse? Good, we have the sine and we have the cosine. Now you say, how do I know which one to use, Pastor Dom? Here's how we know. Okay, what's given to us? Here's the angle, here's the hypotenuse. What side is given to us? Here we have, okay, we have a telephone pole is 15 meters high, is to be supported from its middle. So if the telephone pole is 15 meters high, all right, I know this is not a to scale drawing, so let's go here. All right, the telephone pole is 15 meters high. The support wire's in the middle. How high is the support wire? It is 7.5 meters. Now, again, stay with me. I know this is getting maybe a little boring on you here, but we have the hypotenuse and the side opposite of the angle. You see that, class? So here's the angle. That's the side opposite. What trigonometric ratio deals with the side length of the side opposite and the length of the hypotenuse? All right, Dave Weber. How you doing, Dave? Man, haven't heard from you in a while. Got to get your homework turned in. So, Dave, what do we have here? If this is our opposite, and then we have the hypotenuse, what trigonometric ratio do we have? How about we have Katie Baruch? You didn't think I was going to get you, huh, Kate? Wake up. What do we have? Great. We have the sine ratio. So, the sine of 50 degrees is equal to the side opposite, which is 7.5 meters over the hypotenuse. Now it's easy to solve. Let's get your charts out. Let's look at 50 degrees, and I want you to give me the sine of 50 degrees. The sine of 50 degrees would be, good, 0.7660, okay, equals 7.5 over X. Now G, and how about we have Gianna, then Chris Rob, you follow up. What do we have here? How do I get X by itself? Good, we're going to multiply both sides by X. Okay, so 7.5. And then we have 0.7660X. Divide both sides by 0.7660. And X is equal to, get your calculator out, give you a few seconds to get that, 7.5 divided by 0.7660. What do we have? How about we have Gabe give me the answer, and then we'll have Chris Rob followed up. Great job. 0.9990. 0.99, oh, excuse me. Don't mind me. 9.79. That's the correct answer there, 9.79. So how long must the support cable be? 9.79 meters long, all right? Okay, let's go to number 3. Number 3. Okay, from the top of a cliff, 130 meters above sea level, all right, so I'm just going to draw this. Let's say, all right, we have 130 meters above sea level, okay? The measure of the angle of depression, to a ship is observed to be 18 degrees, okay? So, all right, this is, if it's the angle of depression, there's our horizontal. And from the sight line to a ship, okay, we have 18 degrees. 18 degrees, okay? Now, the ship is 18. How far away is the ship from the bottom of the cliff? All right. Again, we have our right angle, okay? Here's our ship. Now, look at this angle. Would you look at this triangle here? This angle, 18 degrees, is located in what reference to the triangle? How about we have Joey? Joe, where's this angle related in reference to the triangle located? Good, it's outside. It's an exterior angle. So Joe, how would I find this angle here? Once I get this angle, I can determine which trigonometric ratio I'm going to use. So what do we have here? All right, so if this is a 90-degree angle here, if this is 18, how do I find this one? 90 minus 18, which leaves me with 72 degrees. Now, class, the question is, how far is the boat from the cliff? Let's look. If this is the angle, this is a leg, and this is a leg. So remember, if this is the right angle that is formed here, okay, this is the right angle that's formed, what do we have? We have, what trigonometric ratio? This is the hypotenuse. This is the right angle here. This is the hypotenuse. So this would be both legs, which would be the tangent ratio. The tangent ratio. So we have the tangent of 72 degrees is equal to opposite over adjacent. So x over 130 meters. Let's get x by itself. So we're going to multiply both sides by 130. Well, before we get to 130, we should find the tangent of 72 degrees. So I got a little ahead of myself there. So let's do that first before we get x by itself. What's the tangent of 72 degrees? 72 degrees. Gianna, then Emily, you follow up. G, what's the tangent of 72 degrees? And then Emily, you follow up here. Well, look, the tangent of 72 degrees is good. 3.0777. Okay? Sorry about that. All right, here we go. Now, we got to get x by itself. So G, and then Emily, follow up. How do I get x by itself? Good. I want to multiply both sides by 130. All right. This cancels out. So x is equal to, simply get your calculator, 130 meters times 3.0777. And your final answer should be 400.10 meters. 400.10 meters. And so that's the angle of depression because we're looking down from the cliff. All right, let's go do number 5. All right, number 5, we have a road is rising at an angle of 12 for every 25 meters of roadway. How much does the road actually rise? So, okay, all right, here we have a road is rising at an angle measure of, all right, so here's our horizontal. Here's our road that's rising, okay? We want to know how much does the road actually rise? All right, so if this is, okay, 12 degrees, and we have the roadway is 25 meters, how high does the road actually rise? So let's look at the information here. We have an angle, we have the hypotenuse. Now, if this is the angle, are we looking for the side adjacent or are we looking for the side opposite? Caleb Tomlinson, I want you to say it. Then Liam, you follow up. Which trigonometric ratio? If we're looking for the side opposite, and we have the side hypotenuse. Very good. That would be the sine. So the sine of 12 degrees is equal to opposite over adjacent. 12. Get on your table. Look at, don't get on your kitchen table. Get on the chart in your handbook and find the sine of 12 degrees. So the sine of 12 degrees would actually be 0.2079. We want to multiply both sides by 25. So x equals 25.2079. Get your calculator out. We'll have Gabe give me the answer. Then Chris Rob, you follow up. What is 25 times 0.2079? You should come up with the answer of 5.20 meters. The elevation is 5.20 meters. All right, we'll have time for just a couple more, and then we'll finish here. Let's look at number 7. Number 7. All right, let's read this one together. Let me draw it first, and we have... Okay, that's my World Trade Center. So the towers of the World Trade Center in New York City were destroyed by terrorist attacks on September 11th, 2001. Before this date, from the top of the towers, the measure of the angle of depression of a ship 473 meters away was 41. How tall was the World Trade Center? So let's say, okay, let's draw a line to a ship, okay? All right, there's our ship here, okay? Now, the angle of elevation. So, again, if this is our horizontal here, okay, here is the angle formed. All right, we have our right angle here, okay? We have a right angle here. Now, let's put our numbers in. All right, so we have the measure of the angle of depression of a ship 473 meters away. So it's 473 meters away. We have, and the angle of depression is 41 degrees. So 41 degrees. How do I find this angle in here? All right, we did this before. How about we have Brandon Haynes? I almost forgot you, Brand. Not quite. Good to say, Brandon. Brandon, if this is 41 degrees, what's the measure of this angle in here? They are, another word we could say that these are complementary, so the total measure of these angles would be 90 degrees, so 41, take that away from 90, and you should have, what? You've got to get your calculator out, 41, take away 90 would be 49. Okay, ready? Okay, 49 degrees. Okay, now, let's look what's given to us. Here's our angle. We have this side here, okay? Now, I think I'm missing one here. We want to find out how high is the World Trade Center. If this is the angle, this is side opposite, and this would be side adjacent. So we would use the tangent ratio. So the tangent of 49 degrees is equal to, all right, the tangent would be opposite over adjacent. So 473 over x. So multiply both sides by, almost did it again. I'm overzealous. Let's find the tangent of 49 degrees. What is the tangent of 49 degrees? So let's look at that. We're looking at number 7 here. So the tangent of 49 degrees would be 1.1504. 1.1504. Okay. Now let's get x by itself. So let's begin to multiply. X just cancel out. And then we have 1.1504x is equal to 473. Divide both sides by 1.504. Okay, Chris Rob. And then we'll have Bobby Ontlock follow up. What do we have here? All right. 473 divided by 1.1504. And the answer is, trying to find it here. I have it here somewhere, number 7. We have 411.16. So how high are the World Trade Centers? 411.16 meters. That is the angle of depression. All right, so we'll do one more, and then we'll finish for this evening. I'll give you your homework. All right, we have the Statue of Liberty is 93 meters tall. So I'm just going to draw a line. I'm not going to draw the Statue of Liberty. The Statue of Liberty is 93 meters tall. When the measure the angle of elevation of the sun is 50, what is the distance of the tip of the shadow from a point at water level directly below the highest point of the statue? Okay, so we have, all right, the shadow would be down here. And okay, here we have right here. So the tip of the shadow we have would be 50-degree angle, okay? And we want to know what is the distance, how tall is the shadow. So if the sun is reflecting down, all right, we're at a 50-degree angle, what is the length of the shadow? So quickly, let's look at the information that's given to us, okay? Since we know that this is the right angle, this would be the hypotenuse. So we're not concerned about the hypotenuse. So we know we can't use either sine or cosine. So what's left? The tangent ratio. So tangent of 50 degrees is equal to the side opposite, 93, over side adjacent. Okay, get your table out, your chart. Let's look at the tangent of 50 degrees. So the tangent of 50 degrees would be, what do we have? How about we have Chris Rob, and then Preston, you follow up. The tangent of 50 degrees would be 1.1918. Let's get x by itself, so let's multiply, get rid of that fraction here. So 1.1918x is equal to 93. Divide both sides by 1.918. X is equal to 93 divided by 1.1918, and your final answer should be 78.03 meters. That would be the length of the shadow of the Statue of Liberty. Here's what I want you to do for homework this evening, and so we're going to do page 42 and 43. 42 and 43, this needs to be turned in, okay, let's see, have this turned in by tomorrow evening. All right, this is a checkup, this is a quiz, so it needs to be completed, all right? So page 42 and 43, all right? So good, have a blessed day. Hopefully we'll get to see you tomorrow. Goodbye.